Alright, so we are on page 90 in your book. I do have my little kitty sitting on my lap right now, so if you hear a meow or something like that, it's just her trying to be a part of this. Alright, so we are going to basically classify numbers into a set. And we're going to take these numbers that I have listed on page 90, and we're going to classify them as rational, integers, whole numbers, natural numbers, or irrational numbers. So let's just start from the top. For number 1, we have 0.252525 repeating. Now for it to be a rational number, remember that if it's a decimal, then it repeats or ends. This decimal is repeating. Each 25 repeats, so we would say that this number is rational. And it is not an integer, whole number, or natural number, so we would just leave it as being in the set of rational numbers. Moving on to 2, we have the square root of 36, and we're going to take just the positive square root because it doesn't ask us for both. And as you can see, we have the number 6, and 6 belongs to the natural numbers. Belongs to the natural numbers because it's a whole number bigger than 0. It also is a whole number because it is a positive integer. It is an integer, and then it is also a part of all rational numbers. So that is the sets that that number would belong to. And then lastly, for number 3, we have the negative square root of positive 7. Now if you were to find out what the square root of 7 is on your calculator, that would be a decimal that goes on forever and it does not end. So we would say that this number is irrational. Easy way to know if a number is irrational is that if the square root is not a perfect square, then it's just going to be irrational. Okay, moving on to page 90, which is guided practice. We're going to classify the square root of 10. Square root of 10, if you divided that out on your calculator, would be a decimal that does not repeat or end. It just keeps on going forever. So that would be irrational. Belongs to the set of irrational numbers. Negative 2 and 2/5. Well, if we divided that out and we wrote that as a decimal, we would have negative 2.4, which is the same thing as negative 2 and 2/5. And this does not fit our specifications for an integer, whole number, or natural number, but we know it is a rational number because it can be written as a fraction. So we're just going to say that this is a rational number, and that is the only set to which negative 2 and 2/5 belongs. And last but not least, we had letter C, where we're looking for the square root of 100, which simplifies down to 10. And if we classify that number, then we could say that it goes into the natural numbers, all whole numbers, all integers, and lastly, it belongs to all rational numbers. Those are the sets that the square root of 100 belongs. For this last part of the lesson, please try number 1 through 3 on your own for number 92, page 92, guided practice. When you're ready, check your answers, just start the video and see how you did. Good luck. Alright, so for page 92, 1 through 3, we've got 0.050505. It goes on forever. And this actually is a rational number because even though the decimal goes on forever, it repeats. It doesn't end, but it repeats. So we would say that number 1 is a rational number. Belongs to all rational numbers. All right, for number 2, we have the negative square root of 64. Because that negative sign is not with the 64, it's not inside that radical sign or inside the square root sign, we would just say that this is going to be negative 8. Negative 8 is an integer, because remember, integers are all whole numbers, positive and negative whole numbers. And then it is also a rational number, number 8. All right, last but not least, we've got the square root of 17. Hopefully you checked out what that was on your calculator. And if you divide that out or put the square root of 17 in your calculator, you would have a decimal that does not repeat or end. So that's going to be irrational. And remember that if you have a square root of a number that's not a perfect square, meaning it's not like the square root of 9 or the square root of 16 or the square root of 25 where you get a whole number, then it's always going to be irrational. All right, awesome job. We are done.